6, all about rational exponents. So whenever something is rational, it means fraction, right? Rational numbers are numbers that can be written as fractions. They're those decimals that terminate or repeat. So when we talk about exponents that are rational, we talk about like what if 4 was being raised to the power of 3/2, right? That's where we're headed. So let's explore these using a calculator. If we type in the cubed root. So if we want, well, desmos.com/scientific. There we go. So this little N root button, if you click it, it's going to ask you what root do you want to take. So we'll put a 3 up there. And then if we type in 27, you're going to find out that it's 3. And then the flip side of that, if we take 27 to the 1/3 power, we also get 3. All right, and then if we take the square root of 3 to the 4th, we get 9. If we take 3 to the 1/4 power, 3 to the 4 seconds power, we also get 9. Something I also want to call out is that if we take 3, so we take the square root of 3 and then we close parentheses and put that exponent outside, we also get 9. So this representation right here, square root of 3 to the 4th, is the same thing as a square root of 3 to the 4th. It took me a really long time to understand that in my mathematical studies. All right, so here we get 3, we get 3, we get 9, and we get 9. And if you want to write a little note to yourself, this is the same thing as, well, this is the same thing as the square root of 3 to the 4th. Okay, the exponent can be done inside or outside of that radical. So rational exponents, you may have noticed that here, right, we're taking the square root of 3 and raising it to the 4th. We can put that as a fraction in our exponent. And the way to remember this, the way that I remember this is BLTR, so like a BLT sandwich, bacon, lettuce, tomato, ranch. The R is, kind of added in, but bottom left, top right. So when we have a rational exponent, m over n, the n goes to the left, it becomes our index, and then the m becomes our right exponent, all right? Which then is equivalent to if we were to take the root first and then raise it to a power. So practically, we're going to take our bottom number, put it to the left. We're going to take our 216, put it under the radical, and we'll take our top number and put it to the right. And then from there, we could write this as the cubed root of 216, cubed root of 216 squared. So let's see, can we break down the cubed root of 216 following that process? Right, well, actually, it's just asking us to put it in radical form, so we can stop. Right, at this point, let's just stop there. We could keep going, right, and keep breaking down and breaking down and breaking down like we've been doing. But the actual task of the problem is just to write it in radical form. So let's see if we can find groups of 3. Right, there we have groups of 3, and then we have a couple 2's that are going to be left inside. So all of this is going to be raised to the second power. Right, and then we have, let's see, 2 2's out front, and then the cubed root of 2. So we really could think of this as 4 cubed root of 2 squared, which then becomes 16 cubed root of 2 squared, or 16 cubed root of 4. But again, you could just stop right there. If it said to simplify, then you should simplify. And it doesn't hurt to go further than we need to, right? And then the same thing applies with variables. So this z has a 1 right here, so we can rewrite this as z to the 1/4 power. That's what we mean by exponential form. All right, and the rest of your notes is just a few examples. I will go through a few that feel important to discuss. So all exponent rules still apply. If we have a negative exponent, then just send your term to the basement. All right, so this becomes 1 over 81 to the positive 1/4 power, which then becomes 1 over the 4th root of 81. And then as we simplify this 81, we're going to notice that it is actually a perfect power of 4, right? And this will simplify to 1 over 3. All right, here exponent rules still apply, so we have two terms with the same base. We can actually add their exponents. All right, so this will become x to the 2/7 plus 4/7 power, which will become x to the 6/7. So you can leave it in exponential form, or if you wanted to see it in radical form, bottom, left, top, right. Again, we see this negative exponent situation, so we come with 1 over b to the positive 5/6 power. Something to keep in mind, right, is that this is a root on the bottom, so we want to rationalize. All right, we want to get that radical out of the bottom like we did in the last section. So how many more b's do we need in order to make this b to the 6th power? We just need another. Okay, so we'll multiply by the 6th root of b to the 1st power. Multiply straight across, and you'll get the 6th root of b over b. Cubed root of 64 z to the 6th. Let's look at our 64 and see what happens. We'll break this down: 2 and 32, 2 and 16, 2 and 8, 2 and 4, 2 and 2, and then we want to bring them out in groups of 3. So we have a group of 3 and then another group of 3 2's, meaning we have 2 times 2 out front, times the cubed root of z to the 6th, and then think about your z to the 6th like z to the 3rd, z to the 3rd, right? And then each of those can come out front as a z. So we end up with 2 times z times z. We have nothing underneath the radical. We're left with 4z squared. Okay, this example, we want to notice that we have a negative exponent first. And remember, way back in Unit 5, towards the beginning, I suggested that if you have a fraction that's being raised to a negative exponent, just flip the fraction. Okay, so this will become 125 over 1, and that's going to take care of the negative, meaning we're now being raised to the positive 2/3 power. Okay, 125 over 1 is just 125. Bottom left, top right, we're taking the cubed root of 125, and then we can square it. Okay, 125, if we start breaking it down, we should notice that we have 5 and 25, and then 5 times 5, meaning that we have a perfect cube. So this really just turns into 5 squared, which is 25. Last one, power to a power, meaning that we can multiply. Okay, z to the 5/4 times negative 1/5. It's going to be negative 5 over 20, which is negative 1 over 4. So this is z to the negative 1/4 times, and then thinking about our x, we have x to the 3rd power, 3 over 1 times negative 1 over 5 becomes negative 3 over 5. So we have x to the negative 3 over 5. And then both of these are negative exponents, so let's send them to the bottom, right? Z to the 1/4, and then x to the 3/5. We want to multiply in such a way that our denominator becomes rationalized, right? Because this is really saying 1 over the 4th root of z, and then 5th root of x to the 3rd. So we want to rationalize that, okay? We don't like those radicals in the bottom. So how many more z's do we need to get that z out of the 4th root? We have z to the 1st, so we need 3 more. Okay, we're going to multiply by the 4th root of z cubed. And then how many more x's do we need? We have 3. We need to get to 5, so we're going to multiply by the 5th root of x squared. All right, we're going to multiply by the same thing on top. Okay, and then multiplying very carefully. Our numerator is just going to be this, right? 4th root of z to the 3rd, 5th root of x squared. And then when we multiply these 4th roots together, we should end up with z, because that's what we chose, right? We chose to multiply by a certain thing that would give us z, and then we multiply our fifth roots together, we should end up with x. And we are done. All right, you may be wondering, can you cancel out these x's? Can you cancel out z's? No, you can't. All right, the numerators are stuck in underneath the fourth and the fifth roots, so we stop here. All right, take a look at your practice and let me know what questions you have.